All right, we're back. Okay, this time we're going to be simplifying radicals. I'm going to be using all three of those rules from the previous video to solve this huge problem right here. So the first thing we're going to do is I'm going to break this up into three parts, okay? So I have three terms here. I'm going to work on each term individually, and I'm going to try to simplify it all together at the end. So this first one right here, we have the square root of 50. So the first thing I'm going to do is do the prime factorization of this square root of 50. Using the radicals. So now we have the square root of 2 times the square root of 5 times the square root of 5. Okay, the square root of 5 times the square root of 5 ends up canceling out the square root, and you end up just with 5. So you'll end up with the square root of 2 times 5, and then I'm going to reorder this, so then it'll be 5 times the square root. Then I'm going to reorder this so that it's 5 times the square root of 2. So that's that first term, okay? This next one I'm going to bring down the minus sign, and then I'm going to do the same thing here and simplify this square root of 18. So I'm going to have 2 times, I'm going to do the prime factorization using the radicals. So we have 2 times 3, square root of 3, times the square root of 3. Okay? These two square roots of 3 combine to form 3, so you have minus 2 times the square root of 2 times 3. Okay, from here, I'm going to combine this 2 and this 3 to get 6. If you remember, order does not matter for multiplication, so if I move this 3 over here, it'll be 2 times 3. So I can just combine those to get 6 times the square root of 2. Okay, now I'm going to do this last one right here. We have the square root in the denominator, which we are not able to have. So to get rid of this, we're going to need to use the conjugate. So I'm going to multiply the numerator and denominator by the conjugate of this denominator. So instead of 3 plus the square root of 7, it's going to be 3 minus the square root of 7. So 3 minus the square root of 7 for the denominator, and then 3 minus the square root of 7 for the numerator. Okay, I'm going to multiply these out here. So we have the square root of 2 times 3 minus the square root of 7. And then below, all I'm going to do is worry about, because this is the same thing as multiplying the difference of squares. So I'm going to do the difference of squares here, 3 times 3, which is 9, minus the square root of 7 times the square root of 7, which is going to be 7. All right, here I'm going to simplify this a little bit further. So I'm going to put a plus down here, and then do 3 times the square root of 2, 3 times the square root of 2, minus 2 times the square root of 2 times the square root of 7, which would be the square root of 14. Then I'm going to divide this by 2. Okay, from here, I'm going to see if there's any like terms that I can combine. Right here I have the 5 times the square root of 2 and the 6 times the square root of 2. So I'm going to combine these to get negative 1, or negative square root of 2, plus this whole thing right here, which is 3 square root of 2 divided by 2. And this would be my final answer. The radicals, they can't be broken down. They have no perfect square factors. All the like terms are combined. There's no radicals in the denominator. So this would be completely simplified from this big problem up here. So if you have any questions about this, let me know. And if you remember, the last step that you always want to do is plug this whole thing in your calculator. You'll get some decimal approximation that's going to show up on screen right here. As well with this whole thing, the decimal approximation is going to show up right over here as well. And you'll see that this and this are equal based on the decimal approximation. So it's always good to check with your calculator. If you have any questions about anything in this video, let me know.